Have you ever pondered over the vast expanse of the universe and wondered if it has an end? A question that has baffled humans since the dawn of time. As we stare up at the night sky, the sheer magnitude and mystery of the universe can leave us feeling profoundly small and insignificant. Let's take a moment to contemplate the concept of the universe and its seemingly infinite nature. Picture, if you will, the universe as a cosmic tapestry woven with a myriad of galaxies, stars, and celestial bodies. But this tapestry is not static. No, it's evolving, expanding, and reshaping itself in a dynamic dance of cosmic proportions. This theory of an expanding universe can be traced back to the Big Bang theory, a widely accepted model of the universe's origin. Around 13.8 billion years ago, it posits the universe was born from a hot, dense point nearly infinitely small. This event set the universe on an expansive course that continues to this day, growing larger and more diverse with each passing moment. Imagine the universe as a loaf of raisin bread dough. As it bakes, the dough expands, and the raisins, representing galaxies, move farther apart. This analogy may oversimplify the complex mechanisms at work, but it captures the essence of our expanding universe. Each galaxy, including our Milky Way, is moving away from its neighbors, driven by the cosmic forces set in motion by the Big Bang. But what does this continual expansion mean? Is there an edge to the universe? If so, what lies beyond it? These questions are as intriguing as they are complex, challenging our understanding of space, time, and the very nature of existence itself. As we continue to explore the cosmos, we are continually reminded of our limited understanding and the vast unknowns that lie beyond our current reach. We are but tiny specks in the grand scheme of the cosmos, yet our quest for knowledge and understanding is as boundless as the universe itself. So, the universe, as we understand it, is continuously expanding. But what does this really mean for us? Perhaps the answers to these questions lie not just in the stars, but also within us, as we continue our unending quest to unravel the mysteries of the cosmos. Ever heard of Hubble's law or the Doppler effect? Let's take a moment to dive into these scientific principles that shed light on our ever-expanding universe. First up is Hubble's law, named after the great American astronomer Edwin Hubble. His law fundamentally states that the farther away a galaxy is from us, the faster it appears to be moving away. This motion is not due to galaxies themselves moving, but rather the space between them expanding. It's like being on a balloon that's inflating. As the balloon expands, points on its surface move farther apart, even though they're not moving on their own. Now you might ask, how do we know galaxies are moving away from us? Well, that brings us to the Doppler effect. You've probably experienced this phenomenon without even knowing it. Ever noticed how the pitch of a passing ambulance siren changes as it moves towards and then away from you? That's the Doppler effect in action. In the realm of astronomy, we observe a similar effect with light. When a source of light moves towards us, its waves get compressed and we see it as blue, or blue shifted. On the other hand, when the source moves away from us, the light waves get stretched out, appearing red, or red shifted. So when we look at distant galaxies, we observe this red shift. Their light appears more red than it should be, indicating that they're moving away from us. And the more red shift there is, the faster the galaxy is moving. This is where Hubble's law and the Doppler effect come together. Hubble observed that distant galaxies are red-shifted. This is evidence of them moving away from us, supporting the idea of an expanding universe. Moreover, the degree of redshift allows us to estimate the speed at which the universe is expanding. So, in essence, Hubble's law and the Doppler effect are like cosmic detectives, providing us with clues about our universe's past, present, and future. These scientific principles not only demonstrate that the universe is expanding, but also hint at the speed of that expansion. So, the universe is expanding, but what does this expansion mean for us and our future? Let's delve a little deeper. In the grand scheme of things, the expanding universe could lead to several different scenarios, each with its own set of implications. The Big Freeze, the Big Rip, and the Big Crunch are three possibilities that astrophysicists often discuss. Let's start with the Big Freeze. This scenario proposes that as the universe continues to expand, it will eventually cool down. As stars run out of fuel and cease to shine, the universe could become a dark, cold place, void of the heat and energy necessary for life as we know it. Now let's consider the Big Rip. This speculative scenario suggests that the expansion of the universe might not just continue, but accelerate. If this happens, the force could become so great that it would literally tear everything apart, from galaxies and stars to atoms and even space-time itself. Finally, we have the Big Crunch. This is essentially the opposite of the Big Bang. It suggests that the expansion of the universe could slow down, stop, and then reverse. The universe would then start to contract, leading to a massive implosion. This could potentially result in another Big Bang, and the cycle would begin anew. Now, how do these scenarios potentially impact life as we know it? Well, each scenario paints a vastly different picture of our cosmic future. The Big Freeze would mean a slow, gradual end to life, while the Big Rip would lead to a much more dramatic, abrupt conclusion. The Big Crunch, on the other hand, could potentially reset the cosmic clock, leading to a new universe and a fresh start for life. While these scenarios may seem daunting, it's important to remember that they're potential outcomes based on our current understanding of the universe. In this brief journey, we have traversed the infinite universe and its ever-expanding nature. We've untangled the mysteries of the universe's expansion, diving into the depths of Hubble's law and the Doppler effect. These scientific principles serve as the cornerstone of our understanding, providing tangible evidence for the universe's unceasing expansion. We've also delved into the profound implications of an expanding universe. Its relentless growth prompts questions about the universe's origin, its future, and our place within it. The cosmos, in all its glory, is not static but dynamic, perpetually changing and evolving. In our quest for knowledge, we've learned that the universe is more than a static backdrop for the stars. It is an active participant in the cosmic drama, constantly evolving and reshaping our understanding of the cosmos. As we continue to explore and understand the universe, one thing remains certain. The universe, in its majestic expanse, continues to baffle and amaze us, reminding us of our humble existence in this grand cosmic theater.